Do you see my whiteboard? Excellent. Okay, number 8 is relatively easy. Is we have 6 plus 12 plus 18 plus plus 480. I need to compute this summation. Of course, I do not expand it and adding by hand everything now using the formula. You discover, first of all, that this is arithmetic sequence because the common differences is 6. Subtracting this and this, 12 minus 6, 6. 18 minus 12, 6. Okay, I suppose that the rest is the same, you know, because you put that because it's the same. Now, can you see? No? Wow. Sorry. I see it. Emily said I see it. Entonces yo, some problem que you have in internet, miss. Everyone saw whiteboard or no? Let me know, guys, quickly. Switching to the contact view. Okay, let me try one more time. Sometimes happen, okay, you need to. Okay. Now, do you see or no? Everyone saw? Yes. Sophia Monday said yes. Okay, yes. Okay, cool. Okay, entonces I explain question 8 que es 6 plus 12 plus 18 plus plus ending en 480. Es obvio que es arithmetic sequence and the common difference is 6. And the first guy gets A1 is also 6. It's a coincidence. In order to find how many turns, how many times, n times this sequence contains, well, you copy the formula. A sub n is equal to A1 plus n minus 1d. In our particular example, this is 480, que is the last one. This is the first, que is 6. This is n minus 1, and this is 6 also. And the rest is algebra. You apply distributive property, 6 plus 6n minus 6. Wow, let's cancel that and that. And now divided by 6. So far we have 480 is equal 6m divided by 6 both sides, and it's 80. That means our summation contains 80. Entonces finally you apply the formula for the specific arithmetic sequence, que es a sub m, que es, en this case a sub 80, because it's 8 term is equal, bueno, la fórmula general es a sub m is equal to n divided by 2, paréntesis, a1 plus a sub m. In particular, in our example, this n is 80, is 80 over 2, 40, paréntesis, 6 plus 480. So you add it here, 486 times 40, multiplication, the answer is 19,440. Boom. Final answer. Any question? Okay, no problema. Clear. Number 9. Number 9 is, you know, a little bit weird because a summation from n equal 1 to 27 of minus 4m minus 2. You don't be scared that you have minus, because minus is a coefficient, you know. One possibility is apply the property for the summation notation, no? You put it here, you separate into summation. From n equal 1 to 27 is the last guy. And here, in negative 4, I put outside m plus. And here we have minus. You need to remember the formula. Ay, es Helen, ¿no? Helen, putting off the microphone. Wow, Helen. No, I know que accidentally you can do that. Okay, now, continue. Well, so now you remember that formula. The formula K right in the board one day was K equal 1 to M to equal 1 to M. Shui and crazy. 1 to M. Okay, is equal N times M plus 1 divided by 2. In this case, negative 4 is a factor, you know. Entonces, 27 is M multiplication by 28, que es M plus 1, divided by 2. Ese fue. Está fue. And this is easy because the plus is negative to the factor, multiplication by 27, because it's a repeat, it's constant. Okay, nice. Entonces now you multiplication here, you divide first. Divided by 2, 1, divided by 2, 2. So basically negative 2 times 27 times 28 is negative 1,512. And this is negative plus or minus 54. And the answer is negative 1,566. It's obvious that we expect negative value, no? Because every coefficients are negative in this example. It's obvious, right? This part is easy. What's going on? I make a mistake. There. Okay. Number 10. Number 10 is easy. Number 10 is geometric sequence. The first guy, A1, F4. And the common ratio is given case 1/3. They want you find A sub n plus A sub 5. Okay, now since given the common ratio is because it's geometric. Now the A sub m term of the geometric, the formula is A1 R n minus 1. It's a formula. A sub n is then 4 1/3 raised to the m minus 1. Boom. See, leave it like that. This is the answer of this. The answer of this no is numerical because n is 5. See, n is 5, this is 4, 1/3, and 5 minus 1 is 4. Leave it like that? No. You raise to the 4 power. In this case, 4 is 1 to the 4 power, 3 to the 4 power. 1 to the 4 power, 1 is the magic number. When you raise to the any power, it's the same as 1. And this is 4 times 1/81, because it's 3 times 3 times 3 3 times 3 times 3 times 3. This is 9. This is another 9. Together is 81. Or calculator, either way. Entonces the answer is 4 over 81. This is the answer for this. Done? No problema, eh? You let me know. I know it's easy, but maybe you don't understand something. A ver, no problem. Okay, that was number 10. Now 11. 11 say. 11. Again, is geometric sequence. A1 is -2. And the common ratio is -5. Okay, negative. Everything is negative. Okay, don't be scared with the negative. The formula is the same. A sub m is equal to A1 R m minus 1. In our specific example, A sub m is equal to -2. This guy is this. And -5 raised to the m minus 1. Boom. And leave it like that. Because this is, non-numerical is a formula. It's a formula that generates every element, every terms. A5, okay, plus 5. -2, -5, raised to the 4th power, because 5 minus 1 is 4. So you raise -5 to the 4th power. Well, first of all, you see that the exponent is even. When the exponent is even, the answer is positive. At least 5 to the 4th power is positive. Positive something. It's -2 times 625. Because it's 5 times 5 times 5 is 25. And 25 times 5 is 625. So you put in the calculator. Final multiplication is -1250. Multiplication by 2. Cool? Okay. 12. Well, 12 is a little bit more tricky because a summation from K1 to 5 of 2/3 raised to the 2K. Okay, entonces you identification. Number 1 is geometric. So the sequence inside the summation is geometric. Sequence. Okay. I have formula. Yeah, I have formula for the summation. The formula for the summation is a little bit weird. It's A1 1 minus R to the n divided by 1 minus R. You know who is R and who is A1. Okay. Let's do it quickly. There are many ways to do this. However, the efficiency way, okay, I recommend you, when you take calculus 2, you need to use in this series and summations. So now I expand. Suppose for k equal 1. For k equal 1, we have 2 over 3 times 2 to the 1. 2 to the 1 is 2, 2 times 2 is 4 over 3. This is A1. A2. K2 is 2/3 again. Now times 2 to the 2nd power. 2 to the 2nd power is 4 times 2 is 8 over 3. This is A2. And we continue. But I discover if you divide this divided by this, A over 3 divided by 4 over 3 is A over 3 time reciprocal is 3 over 4. Cancel out the 3, and simplification 8 divided by 4 is 2. The common ratio I discovered is 2. Because I am ready to apply that formula. Summation of the 5 element, because n es 5, es equal a A1, que es, A1 es 4 over 3. Paréntesis, 1 minus 2 to the 5th power divided by 1 minus 2. Okay, let's do it quickly because it's easy. Okay, x5 is 1 minus 2 is negative 1 for the third, and this is 1 minus 2 to the 5th power is 32. 32. 2 times 2 times 2 times 2 times 2. 5 times is 30. And 32 minus 1 is 31. So basically, we have so far 4 thirds times minus 31 divided by negative 1. Negative divided by negative is positive. And we have 124, que es the multiplication, 4 times 31 divided by 2. Positive. Boom. Final answer. Any question? Professor can take out the 2 terms as the constant multiply. Yeah. A ver, let me see. You can take the yes, you can. However, so she asked me, see this 2 terms you put outside the summation. The answer is yes. However, you don't solve anything doing this idea, because you need to solving after that this summation. And this summation you ending, no, you focus in this summation, and this summation, for example, the A1, A2, because K1, and the rest is the same, and you ending finally using that formula. 1 minus 2 to the 5th power divided by 1 minus 2. After that, you multiplication by the famous 2 terms. A 2 terms. But in this case, no, I don't know why a 4 term. On a 4 term because it's the first one. Okay, this idea is no good. You try to follow in the formula, because you try to create your own formula, and then you are in big trouble, right? It's my recommendation. No? That's my recommendation. Do you understand very well, Miss? Let's practice 13, it's similar. 13 is similar. 13 is summation K1 to 4 of 1/2 raised to the K plus 1. In this case, no 1/2 we cannot put outside because it contains exponent. But identification that this is look like, oh, I suppose it's similar. Suppose no, I am sure. It's geometric. Because geometric is when you have a base, it's like exponential function. No? You have, for example, 1/2 raised to the something, exponential, or 2 to the x. This is the classical exponential that we study in college algebra. However, here you see in another way, que es like a sequence. What is the difference? Well, the difference is in college algebra, exponential is continuous, and sequence no continuous. 1, 2, 3, 4, 5. Discrete. But let me investigate for k equal 1. What's happening inside this? is 1/2 raised to the 1 plus 1. Is 1/2 square is 1/4. And this represents the first guy in the sequence, A1 is 1/4. And the second is 1/2 raised to the 2 plus 1. Entonces, 1/2 raised to the given power, que es 1/8. I suppose que almost we can predict que the common ratio is 1/2, but it doesn't matter. You divide 1/8 divided by 1/4. So you divide this divided by this. We have 1/8 times 4/1, and 4/8 is 1. The common ratio is 1/2. And the initial A1 is 1/4. And this is the two important elements inside the formula. In the formula of the summation, we have A1, 1 minus R raised to the n power divided by 1 minus R. Let's do it. A1 is 1/4, parenthesis, 1 minus 1/2 raised to the 4 power, because the summation ending in 4 divided by 1 minus 1. Wow, look like horrible because it's a fraction, but no, it's okay, let's do it. Little by little. This is 16. Okay, 1/4, and you are doing according to the order of operations. Okay, the power is first, is 1 minus 1/16, right? And 1 minus 1/2 is 1/2. Entonces this one, you can interpret it like a 16/16. And 16 minus 1 is 15. Entonces es 1/4 times 15, 1/16 divided by 1. Okay, and this is 15/32. Well, basically is, this is cancelled with this. Stay 2 alive. 2 times 16 is 32. 15/32. Yes. Okay, super. 14 and 15 is series. And remember, series is different to summation. Series infinity element. So we have determined whether the infinity geometric series converging or diverging. And remember, the majority of the series diverges because you adding infinity element. However, when the specific condition, so we are talking about series. In the series, of course, we are talking about geometric. In calculus 2, of course, we study another series. For the series, the most important is infinity. Here, K1 to the something, K sub K. Okay? But in the specific case, que es geometric, si es geometric, entonces es A1 R K minus 1, the typical S sub M or S sub K in this case of the geometric sequence. This is convergent. The convergent means, unbelievable but it's true, this infinity element give me one number. When the common ratio, absolute value common ratio is less than 1, they converge. Otherwise, No. So when the absolute value R is greater than or equal 1, even equal, entonces diverge. Okay. So the first example in the question 14. Well, is 5 minus 5 over 3 plus 5 over 9. Okay, I can see how the sign in this series is alternating. The first guy is positive, the second one negative, the next is positive, and I predict that the next is negative. Alternating. It's typical alternating sequence. But the most important is know the formulas, what is the common ratio. So you discover the geometry or no, dividing this divided by this. So says negative 5 over 3 divided by positive 5, eso because negative 1/3. Okay, entonces negative 1/3, of course, the absolute value of negative 1/3 is less than 1, cool, entonces converge. Pero converge to what value? Okay, the common ratio, remember, was negative 1/3. The first guy is A1 is 5. And the formula for the converge is, after you are extracting infinity element, the answer is A1, 1 minus A1 is 5. 1 minus 1/3. No minus, no plus, because the formula have a minus. However, the common ratio is negative. Double negative becomes positive. Okay, so this is 3 plus 1 is 4. 5, 4/3. Entonces, division 5 over 1 times, flip that, 3 over 4, 15. Okay, the infinity sum of the element of this series. Okay, and this is very, very strictly picky. Only converge si es geometric and the common ratio absolute value is less than 1. Otherwise, no diverges. Entonces es obvio, looking, this is the problem 14. But the problem 15 is a little bit stupid because, let me see. Yeah, because it's 13 plus 17 plus 19 plus 21. This is nothing. This is not arithmetic, not geometric. Arithmetic, no. In arithmetic, never we're talking about series. Only convergent and geometric. Because this is diverge. Okay? Because the only possibility to get convergent is to be geometric series and the common ratio absolute value should be, must be less than 1. Clear? Clear? Okay. So now in the test, yes, okay. In the test, we have only one question about mathematical induction. It's very confusing. It's powerful method to prove something. However, it's for too long or confusing, This problem is 16 is equal 2 plus 5 plus 8 plus bang, 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 3n minus 1 is the a sub n term should be equal n over 2, 3n plus 1. and prove this using mathematical induction. Remember, mathematical induction contains two steps. The basic step, in which you prove the statement for k equal 1 or m equal 1. Doesn't matter if it's k or it's m equal 1. N equal 1, we have the first guy get 2. And it should be, when you plug it into here, you get the same value. Let me see, 2 over 2, 3 times 2 plus 1. Entonces es 3. Ahora, I make a mistake, ¿no? I make a mistake. I copy wrong. I copy right. Yeah, I copy right. Es n equal 1, no 2, no. N equal 1. N equal 1 is 1/2 3 times 1 plus 1. Okay? This is basic step is with n equal 1. This is 4 divided by 2. Wrong. Okay, cool. And the inductive step. And under the supposition that S sub k is true, you will be able to prove that the next is true. You assume this, so you will be able to prove okay, under the assumption that this is true, imply somehow that this is true, and this process continues forever. This is the idea. This is easy. When you copy the original example using no m, no k. And who is k? Well, k is intermediate value, arbitrary, any value. N is the last one. K is in the middle. Suppose N, the last one is 50, 49, 48. It's a K. So now, you copy exactly the same original problem, but now you replace N for K. So 3K minus 1. That's equal K over 2, 3K plus 1. And you assume it is true. Okay. Now I try to investigate the next. The next is k plus 1. K plus 1 is exactly the same. Three. 3k plus 1. 3k minus 1. Sorry. But you include a new one. A new one is replaced k plus 1. So is, let me try to do the algebra here. 3k plus 1 minus 1. So it's 3k plus 3 minus 1. 3k plus 2. This is logical. 3k plus 2. Make sense, right? Likewise, you are doing in the right hand side is k plus 1 over 2, and here is 3 k plus 1 plus 1. It's different to this. This is minus, this is plus. 3k plus 3 plus 1 is 3k plus 1. It's 3k plus 1. It's easy. Look. The only thing that we are doing is including one extra term in the expression, is k plus 1. And the rest now is algebra. Because remember the assumption we are doing, that part is equal to this. K over 2, 3k plus 1 plus 3k plus 2. I need to prove using algebra que es igual a this. Well. Let's do it. Find the LCD, least common denominator, and that part. Because I want to condense in this and this in only one expression, the least common denominator obviously is 2. So it's k, 3k plus 1, plus 2 times 3k plus 2. And I don't touch that part for a moment. Now distributive property, 3k squared. Distributive property plus k plus 6k plus 4 divided by 2 combined later is 3k squared plus 7k plus 4 divided by 2. Okay, stop. Leave it like that for a moment. Now, in that case, super easy because I see K2 we have in the bottom, and you foil that. You multiply 3k squared, 4k, 3k, and 4. One more time, we combine later, we have 3k squared plus 7k plus 4 divided by. Boom. And this expression is identical to this expression. And we prove that for mathematical induction, you prove. Yes. Do you understand the idea or no? Yes or no? Confusing. Come on, guys, this is the review. So you don't understand something about the procedure or algebra or something, let me know, no? No? Everything is okay? All good. Okay, Sophia. Okay, let's move on to the binomial theorem. Binomial theorem is easy, in my opinion. 17. 17 is 2x plus 3 raised to the 5th power. Okay. Entonces now you have, in order to find the coefficient of binomial, you have two possibilities. Or doing the Pascal triangle, 1, 1, 2, 1, 1, 3, 3, 1. You remember the rule, no? You adding this and this, and you get that. 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. And just stop, because it's 5th power, no? A 5th power, right? A 5th power, okay. The next is 6th power, okay. The next is the next. So this is the coefficient we are using in this question, 17, no? Okay. Es, remember the idea is a summation from K0 to 5 of the A sub K, but who is A? A in our problem is 2x. Raised to the n minus k. And B, F3 raised to the k. Something like that. Pero no, I don't like this. You expand for k equals 0. For k equals 0, entonces I forgot, important, the coefficient que es nk. en el formula for the Newton. Ok, entonces, pero the coefficient no importa because I see for this part. The first coefficient is 1. Okay, cool. And we have 2x to the fifth power. After we manipulate a little bit. And no b. This is a, and this is b. No b, because it's 0. Plus 5. Why 5? Because this is the coefficient. 5 times 2x raised to the 4th power, you decreasing this exponent, 5, 4, 3, and so on. And b, 3 to the 1. Keep in mind that 4 plus 1 always is 5. So the sum of the exponent always is 5 in any term. Where's the next guy? No, the next guy is 10. What 10? Look at that. This is coefficient. 10 to 2x to the 3rd power. And b get 3 to the 2nd. 3 plus 5, 3 plus 2 is 5. Plus, where's the next? The next is 10 again, no? 10 again. Look, 2 10. 10 10. So it's 2x raised to the 2nd power and 3 to the 3rd power. Plus 5. 5 what? 5 to x to the 1 power. You know, 1 is invisible. Exponent. You want to put, it's okay. And 3 to the 4th power. This is the last. No. Remember, we have 5, we have 6. 1, 2, 3, 4, 5. One more. The last one is 1, which is 1. Invisible. Okay. Is 2n to the 0 power is invisible as 1. And 3 to the 5th power. Cool? The rest calculator. 2 to the 5th power 32. 32 x to the 5th power. Plus, you multiply now. 2 to the 4th power 16. 16 times 5 is 180. 180 times 3 240. No, sorry. 16 times 5 is 80. 80 times 3 240. 240 what? X to the 4th power. Plus, and this is a little bit more complicated, but it's 2 to the cubic power is 8, multiplication by 3 to the 2nd power is 9, and 8 and 9 is 72, 72 times 10 is 720 x cubed. Plus, this is 27, this is 4, and this is 10, is 1080 x squared. Plus, the rest is 810 x plus 243 gets 3 to the 5th. And this is the answer. This is the expansion totally of this binomial 2x plus 3 raised to the 5th power. Important detail. See the exponent is 5. You expect 6 terms. 1, 2, 3, 4, 5, and 6. Why? Because the first one is K0, K1, K2, K3, K4, and the last one is K5. Okay, that is the reason that we have one more. Clear or no? Let me know. Binomial. Binomial is clear. Yeah. Martin Sepper. Okay, Martin. 18 is very, very similar, except it is W minus S to the 6th power. Entonces, si es to the 6, we continue the Pascal triangle one more. 1, 6, 15, 20, 15, 6, and 1 is the Pascal. And the coefficients is 1, 6, 15, 20, 15, 6, and 1. Another detail in this problem es que es negative. Entonces now you don't worry for this too much because you consider W like A and you consider B like a minus S. Then when the exponent in the B is even number, que es minus S, the answer is positive. Si the exponent in the B, que es minus S, is odd exponent, es negative. That is the reason that when you are doing the expansion of our summation, our binomial, and we have positive, negative, alternating sign. Okay, so now this is the coefficient, the exponent you know start in W6. Okay, the first A to the exponent. Plus or no, plus or minus, I don't know. There's 6, is this guy, W5, and minus S. Do you see that? To the 1 power. Entonces, actually, es minus. Okay, entonces no necesarily write like that, no. More elegant, in my opinion, is S, y put the negative here, right? The any coefficient of the S, que es odd, is negative. Any coefficient of the S, que es even, is positive. Because you consider it as negative. What's the next? Well, the next is 15, 15, W4 and X squared, right? Pero entonces es positive because it's even. Minus 20, W3 S3. Yeah, I know it's negative because the exponent is odd exponent, odd number in the S. Plus 15 W squared X to the 4 power, even, positive. We continue. Minus. It's alternating, guys. Plus, minus, plus, minus, plus, minus, plus. The next is minus. The coefficient is 6. 6W S to the 5th power. And it's logical because 5 is odd number, it's negative. And the last one is S to the 6th. Done. Final answer. Entonces we have two examples in which you need to expand totally the binomial. And we have in the test another two examples, or one, I don't remember very well, in which you need to find a specific. Depends if you select the number of the term or you specify one specific. Let's come back to the review. The review say the coefficient of the X in the expansion. 19, they want, okay, you find, okay, let me try to explain this part. Any question 17 and 18, it's clear or no? It's clear or no, guys? Clear. Okay, enough. Okay. Suppose this is the binomial is given. 19 is 9x plus 3 cubic. But they want, let me read again. The coefficient of x in the expansion of this. But it's 6 or 9? It's 6. I copy wrong. Okay, so now I know the formula. The formula is summation k 0 to 3 and k combinatory number or whatever, or in this case, easy Pascal. A N minus K BK. It's a general formula. Our specific example is 9x. So basically, I try to investigate what is the K value in which X is 1. Okay, because the combinatory number is 3K, I have no idea who is K. A, I know que es 9x raised to the n minus K. And B is 6 to the K. In our specific example. But they want when the exponent of the X is 1. Sorry, I put n here, no n, it's 3. Our specific example. Therefore, 9x, no 9x. Therefore, hey professor, I need to go to the medical appointment. Okay, no problem. Watching the rest of the video after, right? Okay, now the important thing is the exponent. Well, actually, I focus in the x part. The exponent is 3 minus k, and this should be 1. Look, should be 1. Therefore, 3 minus k is 1. Therefore, k is 2. So 3 minus 1 equals k. K is 2. Okay. K is 2. Si k is 2, well, the rest is easy because plugging in 2, yes, combinatory number 3, 2. 9x to the 1 power, because I discovered it as 2, 3 minus 2 is 1, and 6 to the second power. Okay, so now multiplication, this combinatory number, we can use a Pascal, or either way, 1, 1, 2, 1, 1, 3, 3, 1. This is K0, this is K1, this is K2. Wow, this is 3. This guy 3. After we complete with the formula. 3 multiplication by 9x, multiplication by 36. The answer is 972x. End the story. Let's compute this without Pascal. 3 factorial divided by 2 factorial, 3 minus 2 factorial. 3 minus 2 factorial, 3 minus 2 is 1. 1 factorial is 1. 2 factorial is 2. And 3 factorial is 3 times 2 factorial. So 3 times 2 times 1. Cancel, the answer is 2. But it's easy in Pascal. Of course, it's easy when the number is small number, right? So it's big number, much better the formulas. Okay. Let's go in the last one. The last one is different because in the last one, day 1, so we have binomial 20. The question 20. We have x plus 3y raised to the 10 power, but I need the 9 terms and the expansion. So the tricky part is one, okay, with A is x in the formula and B is 3y. Cool. But 9 term means K is 8. How do you know that? Because we have 11 term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. This is K0, K1, K2, K3, K4, 5, 6, 7, 8, 9, and 10. So, this is the 9 term, but this is K equal 8, 1 less than. Because this is K, However, this is the first, this is the second, third, fourth, 5, 6, 7, 8, 9. It's the guy que I need, que I want, the K is 8. More clear now? Bueno, entonces easy. Combinatory number 10, 8, because K is 8. A is X to the 10 minus A, the formula. I copy the formula one more time. The formula say combinatory number NK, A N minus K, BK. And B is 3Y raised to the K power, que es 8. Wow. So now you compute that. This is complicated. Let's do it. 10 factorial divided by A factorial 10 minus A factorial. Bueno, 10 minus A factorial es 2. Y tu factorial es 2, que es 2 times 1. Entonces es 2. You expand. 10 factorial is 10 times 9 times A factorial. I stop here because this A factorial is cancelled out. This A factorial. Entonces es 2, 10 divided by 2 is 5, times 9 is 45. This number is 45. This number is 45. And so far we have 45 x to the second power, 10 minus 8 is second power. And 3 to the 8 power, you put in a calculator, is 6,561 y to the 8 power. And when you multiply each other, the answer is 295245. This is 295,245. X to the second power, y to the 8. Cool. So we finish. Guys, after, when you finish and you get good grades, I appreciate so much que you express your opinion in ratemyprofessor.com. You like the way I teach, no? Some people, so only in ratemyprofessor.com write the opinion the student que love me or hate me, depende, no? Your performance in the course. But it's okay. It's totally optional, totally voluntary if you want to express it. So I enjoy too much this class, guys. Remember, Wednesday we have no lecture. We finish today. Don't forget to submit homework, test online, and try to send me by email written test. Okay, remember the day is not 27. Okay, thank you. Pleasure anytime. Bye, guys. Good afternoon.